Dr. Somnath, you joined ISRO at Vikram Sarabhai Space Center following your degree in aerospace engineering in 1985. You've served in many roles and you are currently the director at the VSSC. What was your first role when you joined Vikram Sarabhai Space Center in the 1985?
I joined as an engineer in SLV Project. SLV Project was just only 1 or 2 years into after the approval, so I joined the SLV Project team. At that time, the project director was Dr. Srinivasan, and Mr. Madhavan Nair, who became later the chairman, was associate project director. I was put in responsibility of integrating the rocket. So at that time, the rocket was still on paper. So we were designing it. So I was responsible for designing many of the internal systems of the rocket. For the first 10 years of my service, I worked in the SLV project. So I saw its first launch, which failed. Then I was working in the project for the second flight, which was successful. So by that time, I had a lot of specific work in the project, designing many of the systems that actually flew in PSLV.
Now you know, we all know that space is very tough. You have failures, that's quite normal. Even the SLV-3 had its problems. But at that time, when you were very young, it was your first project, how did you feel when it didn't work?
When I joined, it was a time which was quite a tough time for ISRO. The ASLV project was not going through in a very good times. We had one failure, and the second failure was about to happen after my joining. So after that failure, people were actually mocking at us. When we were out in the city, boarding our VSSC bus to go to office, people will come and tell us not so nice things, because we were looked upon as somebody who is bound to fail, and always the name that was given to ASLV was always sea launching vehicle. So it was going to the sea all the time. So you can imagine the type of motivation that we will have when you hear all this around us. And remind you that we are working in the next launcher, which is PSLV. Even before the ASLV was successful, we were working on PSLV. And we were establishing a new facility at Trivandrum, Valiyamala, the new place where we were integrating PSLV was coming up. So it was a very tough time.
But you had, I think at that time, the ISRO director was Satish Dhawan. Is that right?
At that time, Satish Dhawan was just leaving, and Professor U.R. Rao was just taken over.
Yeah, now I understand in both Professor Rao and Satish Dhawan, they provided very supportive management environment. Would you agree with that?
Definitely, yes. The approaches of both these leaders were exemplary. Satish Dhawan was the first person who actually converted the distributed R&D work into very focused work towards delivering something. So if the Sarabhai's time, it was more or less everybody was doing everything, and there was no definite direction of what you want to get out of the whole exercise. That was not very clear at that time. But when Satish Dhawan came, he made it very, very clear that what we want to make is a launch vehicle called SLV-3, and he formed that SLV-3. And many of the work which was done in a very random fashion around the ISRO centers were coordinated and brought to very focused way for achieving SLV-3. And in that process, he made many of the activities which are beyond that scope of SLV-3 not to progress. So he suppressed them so that this was given all the importance. And that was the thrust that he gave to that. It led to the development of the vehicle as well as development of many facilities which are the current strength of ISRO. And later, when Professor U.R. Rao came, U.R. Rao is also known for a specific contribution in creating the spacecraft. That team. At VSSC, he was leading the spacecraft development team. Later, which moved to Bangalore and created the initial centers. And he built the whole thing from scratch. Nothing was there at that time. So he had the vision to build it. He had the passion to build it, and his team was so great, and they had developed from nothing the spacecraft design capability and manufacturing capability in Bangalore, supported by all the centers around, like Space Application Center, the LEOs, Vikram Sarabhai Space Center. All these people contributed. LPSC, later came LPSC. So all of them contributed to make the spacecraft. So they were great leaders. More than research, they were focusing on delivering something out of the whole exercise. So that is their style.
It's an exciting period in ISRO's history. All of the periods of ISRO's history are exciting. Before you came to your current role as director at VSSC, you were director at the ISRO Propulsion Center. Now, just give us an outline. I understand all the solid propulsion is manufactured at Sriharikota. What about the liquid and semi-cryogenic and cryogenic fuels? Where are they produced and how do you get them to Sriharikota?
See, we have a concept of distributed work concept. For example, solid propulsion was originally developed in VSSC. We continue to make a lot of solid motors in VSSC. We have a plant called the Rocket Propellant Plant, where we make all the strap-on motors of SLV. Even today it is made there, manufactured. That means made means the casting of the propellant is being done there. And for the bigger motors of 2.8 meter and bigger size, it's done only at SHAR because it is difficult to move those motors on in public roads. So that facility was built as part of the SLV project at Satish Dhawan Space Center. So all those motor parts are manufactured there, but the design team is at VSSC. The manufacturing responsibility is with Satish Dhawan Space Center. But when you talk about there are various other elements of a solid motor, which includes nozzles, igniters. They are all done at VSSC. So they come from VSSC and then get integrated at Satish Dhawan Space Center.
That's quite a distance. How long does it take to transport on road?
On road, it takes 1.5 days.
1.5 days.
Yeah.
And why not use? I mean, Sriharikota is on the coast, and VSSC is pretty much on the coast. Why not use sea transport?
Oh, we have been thinking about it. We have been working out plans to build a sea transport route. Maybe when the hardwares are too big and finding it difficult with increased transport, congestions in cities and roads, we may think of such an opportunity. But we have proposals of that type, and definitely it is possible.
And I understand India has some very strict environmental controls, so you can't ship hazardous materials in the areas where there is fishing, for example. So I'm sure there's
no. I'm not aware of any such constraints because any hazardous item can be shipped provided it meets certain norms. Yes.
Okay. I just talk about some of the activities now up to date. This year you've had 4 launches that have been very successful, but you did have a problem with one of the communication satellites. There was a problem with the electricity. Did you discover what did the failure assessment committee conclude was the cause of the electrical failure?
Yeah, you may be referring to the GSAT 6A failure,
That's right.
which had a problem which was observed after launch. Of course, we have been doing a lot of simulation tests in ground to find out what could have gone wrong. And the present understanding is with respect to some of the harnesses which would have got damaged due to overcurrent.
Yeah.
And that assessment is available, and based on that assessment, further spacecrafts all have been improved or modified to take care of such a failure.
And that's part of the learning cycle.
Yeah, yes.
Now, you've got a busy period coming up for what's left of this year. You've got GSAT 11, GSAT 31 to be launched by ESA. Do you have launch dates for those? Are they?
As far as I know, the launch dates of GSAT 11 is by 4th of December, and 31 maybe. Exactly, I do not know, maybe in the beginning of next year.
Now, you mentioned PSLV, you've got PSLV 43 coming up. That's a very reliable launch vehicle. But you're also coming up to the second developmental flight for the GSLV Mark III.
Yes.
When is that due? How's that coming along?
The PSLV launch C-43 is scheduled by 17th of November. Now, the dates are already announced. And the GSLV Mark III development flight D2, that is now scheduled by the first week of November, that is 5 to 10 November. So currently the vehicle assembly is really progressing and all the items are at launch station. And we are waiting for the spacecraft to come, and once that comes we will be integrating maybe the end of October and then go ahead with the launch.
And what's the process? These are still, you're still calling it developmental flights. After how many developmental flights does it become operational?
As on today, we have a project report which states the whole plan, because while getting approval of the project itself, we have defined how many development flights will be there. The original project reports talked about 2 development flights. And subsequent approvals are available for us to proceed with the operational flights. So, but we had in between one more extra flight we added called the experimental flight. So, and that we got approval from government separately. And so we will have 1 experimental flight, 2 development flight, and after that will be operational flights.
Now I've got to ask you, one of the most exciting missions is the return to the moon. It's been 10 years since India was last there with Chandrayaan-1. Chandrayaan-2 is an orbiter, lander and a rover. Still currently scheduled for launch in January?
Yes, the current date is the first week of January.
And have you been involved in that? I know a lot of the work for the missions takes place at VSSC. Have you been involved in that?
Yeah, I was involved in that project in different capacities as director LPSC. Okay, because that was a time when we were developing the engines required for Chandrayaan-2. It's a new engine. That's called a throttleable 800 Newton engine. That I was there, part of the developmental team, and we have completed all the developmental tests for the engine. The first time that we have developed a throttleable, that means thrust can be varied up to 40% of its starting thrust to enable us to land in the soft mode. So that engine now got developed, qualified. Now that is already integrated for the flight craft. That was, and it requires a certain throttleable regulation system. It also has a controller which is an electronics, and all those things were developed. The algorithms were developed, tested. Currently we are doing testing in the floating condition, in a hanging condition, to demonstrate the software and the hardware. So that was one contribution at LPSC. When I came to VSSC, the team at VSSC contributes in a different way. We supply the thermal analysis support, because we have an expertise in VSSC on modeling of the plume. Because on landing on the surface of moon, there will be a lot of dust coming out, and how the dust is going to impact on the engine and on the thermal environment, this is specifically studied. We also studied the heating due to the engines and how it will affect the various elements within the Chandrayaan lander. And there is also a team at LPSC who studies. So both these teams study this in using different tools, and we arrive at what type of protections are to be done. We also have systems that are supplied from VSSC, many items like the propellant, pressurization bottles. Then there are payloads which are manufactured at VSSC.
Yeah, a lot of that takes place. I mean, not many people are aware of that. So are any of the instruments on board, either the rover, the lander, or the orbiter, made exclusively at VSSC?
Yes. There are instruments made at VSSC, which is going to be part of Chandrayaan. We have a team called the Space Physics Laboratory. It is a separate unit with its own director, but part of the VSSC they do the studies related to various physics aspects, atmosphere, planetary science, and they do fundamental research, and they also build instruments which were part of the Chandrayaan-1 Mars orbiter as well as Chandrayaan-2.
And I know originally it was going to be a collaborative project with Russia, but now it's entirely Indian project.
Yes.
Orbiter, lander and rover. What's the mission duration for the rover and the lander on the surface of the moon? Will it be just a couple of weeks, or the duration of
Yes, yes, it will be because of the very important reason that we need solar power to keep the craft running.
Yeah.
And the typically on the day of moon is only 2 weeks. So a moon cycle, that we
2
will
days.
two weeks we will have day, and another next 2 weeks it will be night. So what we think is that after the lander has just landed, it will be the beginning of the day starting. So we will get 2 weeks of time to keep the lander and the rover live. So we need power generation. Basically, the temperature has to be controlled. We have to keep the communication on, and the battery should not be drained. So at the end of these 2 weeks, everything goes down. The power will be lost and communication will be lost. But hopefully, after going through the night, where the temperatures can go extremely low, occupants, if they survive, and the next day when it starts and it power ups and starts, we will have time. More next. One more life we will get, but hopefully.
You never know, and the temperature at night goes down to below -100 degrees C, so it's very tough on the instruments. So you think there's a possibility that after the first 2-week-long lunar night, it may come back to life when the sun.
We are not expecting right now that it will happen, but if it really happens, it will be really a bonus to us. But our current plan to complete all the experiments and investigations within the first 2 weeks, and that's how it is designed for.
And given the timing, you said you want to arrive essentially in the early morning of the lunar day. So if you miss that window, you'll have to wait essentially another month, won't you? It's this,
yes.
Launch windows.
Yeah, so our windows for launch is determined by the time of arrival.
And then just one last thing, if I may. There's been recently, this year, you inaugurated a new vehicle assembly building at Sriharikota. That I take is in operation now?
No, that vehicle assembly building is just completed.
Oh, I see.
We are yet to start the vehicle assembly operations from
right,
there.
so operation will start, the building's complete.
Yes.
What about, this talk has been around for a long time, for another launch site. Currently all the orbital launches take place from Sriharikota in India. Are there, what's your view about plans for additional launch sites in India?
Well, if you look at the current scenario, we need to first justify why we need another launch site. If you look at the current capability of Satish Dhawan Space Center, we are not even utilizing its fullest capability. The number of launches, if you look at the last year, it has been 6 or 7. And we are trying to increase it to something like 12 to 18 launches per year. If it goes well at SHAR, the capacity by 2021 will be around 22 launches per year.
So what's holding it back? Why not have that frequency of launch?
We are trying to build that capability. See that it comes due to many reasons.
Right.
It is not generally, it's not detected by the launch site at all. It is detected by the capacity of the Indian industry to produce these rockets.
Okay.
So if you have rockets, we can actually launch 2 numbers every month. So that means 24 launches, 20 to 24 launches can be handled from Satish Dhawan Space Center without any problem even today.
Right.
So what we are now trying to do is to create the industrial capability of producing PSLVs. PSLV currently the production rate is only 6 to 7 launches per year. That's the capacity currently having in industry.
Right.
We have been discussing with industries to produce up to say 12 or 18. And GSLV Mark III current capability is only 2 per year. We are trying to make it to 4.
Right.
So for that some other facilities like solid motors production facility we have already expanded at Satish Dhawan Space Center. And the manufacturing of the motor case and structures in HAL, L&T, WAL and other industries, we are now requested them to double it.
Right.
So once all this happens, our number of launches will increase. And if you really cross 20 or beyond, then we should discuss about another launch pad. Until then, I don't know whether it will be worth to invest huge cost to build another launch site.
Now, I remember in Professor Rao's book, he wrote about the move from the SSC to Bangalore was in part because the local industry available in Bangalore, thinking of Bangalore Electronics Limited and many others, was much richer and more advanced in Bangalore than in Kerala. So that was mid-1980s when you joined. So industry, the capacity for Indian industry to support ISRO's project is still well beyond what you really need.
In terms of volume, yes, they are not. They are not meeting the requirement even today. We are discussing with many of our partners to enhance their production capability. But with respect to technologies, they are really up to the level, and they need to upgrade the whole technologies also to the next level, as what's happening in Europe and America. So for that, also there are discussions taking place with companies and industries in Europe and America by our partner companies to enhance their own technological capability in manufacturing, not in design, so that we will be able to produce lower the cost. Production time can be decreased. So all these aspects are also under discussions today.
And it's, if you look forward to just the future plans, you've got missions planned to return to Mars. And in fact, it was the 4th anniversary of Mars orbiter mission only last week or so.
Third anniversary.
Third anniversary. 4th anniversary of the launch, but yeah, 3rd anniversary. And it's been remarkably successful.
Yes.
You've got missions to go back to Mars, mission to the Moon, you've got Aditya L1. What else is in the distance vision of ISRO? What do you
Probably you are aware of the announcement of the human space flight.
Yeah, no, I haven't mentioned that, but yes,
so
you've been involved in that too, haven't you?
Yeah, that's the most exciting thing that is now recently been announced.
Right.
So we are getting ready for that project to take on and then achieve it in the time frame that has been set.
Now, briefly, you were involved in some of the pre-flight testing for some of the technologies associated with human spaceflight program. You've done you've done 2 capsule return experiments and the pad aboard test. Were you involved in the pad aboard test?
Yes, as a director, I was in charge of that test.
Right. Now I've seen the video of that, and it seemed to be successful. But on the video, you see the parachutes detaching a little earlier. Was that planned?
No, that was planned with a certain timing.
Right.
So it has occurred at the timing.
Right.
What has been planned.
Right. And from other measurements that I'm sure you collected these tests. How was the test in terms of?
There were a lot of uncertainties to start with.
Yeah.
And we have been simulating it for some time to understand the dynamics. So there are finer aspects which includes the way in which the parachute comes out, and also the way in which the capsule and the crew escape system will separate out. And the crew module has to do a 180-degree turn by itself.
Oh, I see.
And the aerodynamics should enable it to happen. Then only parachute will separate in the reverse direction.
Yeah.
And we were expecting that will happen because of the understanding of the aerodynamics.
Yeah.
And it perfectly happened.
Right.
And we were also worried about the rates, that is motion of the craft during the parachute coming should not exceed certain degrees per second.
Right.
And it was just at the brim.
Right.
So that was also a wonderful assessment we made, and we made sure it was threadbare, discussed, analyzed, tested, and it is very happy to see that actually happened like that.
Right.
And parachutes entanglement is another very big danger in such processes, and it went out well. Both the parachutes were beautifully expanding and coming out, and the rates on accelerations, which are limited by it, they're also meeting the requirements.
Right.
So overall, we have seen we don't have major anomalies. That is really going to tell that your design is wrong. No, it was really perfect, near perfect about condition.
And when you have the eventual mission with 3 people on board, was a weight simulation assuming 3 people on board, and will you still have 2 parachutes?
No, right now what we have designed, what was launched was with a 2 people craft.
Right.
For 3 people, there will be some modifications, designs may be required. A little mass increase will be there. But what you had seen is that the earlier design was enough even with 1 parachute to land safely to meeting the requirements. The second parachute is actually a redundant parachute.
Okay.
So we know that today with these 2 parachutes, it's okay for the 3 people craft to manage for landing.
And what about the spacesuits? That must be something new. for India. Are you developing these spacesuits in-house within ISRO, or is it being outsourced?
What we are developing is a flight suit, not a space suit. Flight suit is a suit that you will wear. That will be worn during the flight within the module.
Right.
And that's good enough during the launch and the descent phase, but not enough for an EVA, extravehicular activities. And that will be a new suit that we have to develop, if at all we take it for the future for extravehicular activities.
And you expected to hit the target of 2022 for the first flight?
Yes.
Dr. Somnath, thank you very much indeed. Really appreciate your time.
Thank you so much.